And welcome back to my channel. In today's session, we are going to solve some of the most interesting HackerRank SQL solutions. So I'd suggest you to please check out the description box where I'll attach the problem link so that you can just follow along with me. So let's begin.
So we are given a company hierarchy, which is shown here: founder, lead manager, senior manager, manager, and the employee. And we are given some tables, and we are supposed to write a SQL query to print the company code, founder name, total number of lead managers, total number of senior managers, total number of managers, and total number of employees. And the last, we have to order our output by ascending company code. So we are given that the table may contain duplicate records, and we are given five tables: company table, lead manager table, senior manager table, and manager table, and the last, the employee table. And we are given the columns that are in each table. So the company table has two columns: the company code and the founder. The lead manager table has again two columns: lead manager code and company code. Senior manager table again has three columns, so these are the listed names of the columns. Similarly for the manager table and for the employee table. And these are the sample tables, and this is the sample output. So here, this is the company code, this is the founder name, this is the number of lead managers, this is the number of senior managers, and this is the number of managers, and this is the number of employees. So this is how our output should look like. So let's begin writing the query. So since we are given five tables, so we are supposed to join all these tables in order to find the result. So let's start joining the tables. So the first table that we have is the company table, company C. Let's join this table with the lead manager table, lead manager L. So I'm giving the alias to the company table as C and the lead manager table as L, and I'll be joining the inner join operation here on the company code. So C dot company code. Company code is a common column in both the tables. So C dot company code is equals to L dot company code. Now we will be joining another table, which is senior manager table, senior manager S. So I'm giving alias as S here. On again, we will be joining it on the company code, since we have the company code as the common column in both the tables. So C dot company code is equals to S dot company code. Next, we are supposed to join another table, which is the manager table. So manager, I'm giving alias as M on. Again, we can do the join operation on company code equal to M dot company code. And the last, we have the employee table. So employee on, again we can join on company code. So this is the common column, is equals to E dot company code. So we're done with joining operation of the tables. Now we are supposed to write the column names that we want to extract. So since we want to print the company code, so the first of all, company code, C dot company code, which is in the company table. The second, we have to print the founder name. So founder name is also in the company table. So C dot founder. Next, we are supposed to find the total number of lead managers. So to find the total number of lead managers, we will be using lead manager code column. So we will just apply the count function on lead manager code. So we'll just count the number of lead manager code, and it will give us the total number of lead managers that we have. But since the lead manager code can have duplicates, so in order to remove the duplicates, we will use distinct function, distinct of L dot lead manager code. Similarly, we want to find the number of senior manager code. So again, we will be using the count function on distinct of senior manager code. So s dot senior manager code. Next, we want to find the count of managers. So distinct of m dot manager code. So here we see manager code. And the last, we want to find the count of employees. So e dot employee code. Okay. So here we have the employee code. So this way we can find these counts. At the last, we want to group by to the company code and founder name. So the columns which are not aggregated, so these two columns which are not aggregated, we are putting them into the group by function. Now at the last, we wanted to do order by to the company code. So yes, this is our query. Let's run our query, our final query, and see the results. So finally we have got the answer. We can see that our output has the company name, and this is the founder name, and these are the counts of lead manager, senior manager, count of managers, and count of employees. So yeah. So here we are given that Julia just finished conducting a coding contest and she needs your help assembling the leaderboard. So we want to write a query to print the respective hacker ID and name of the hackers who achieved full scores for more than one challenge. So this is our question, and we at the last it's giving us some details about how do we need to order our output and all those things. So let's go through the tables data. We have four tables over here. Hackers table. So the hackers table has two columns, hacker ID and name. So hacker ID denotes the ID of the hacker and name is the name of the hacker. The second table is the difficulty table, where we again have two columns, difficulty level. So the difficulty level is the difficulty level of the challenge and score is the score of the challenge. Now there is the third table. The third is the challenges table, and we have three columns over here. Challenge ID is the ID of the challenge. Hacker ID is the ID of the hacker who created the challenge, and difficulty level is again the difficulty level of the challenge. So for the second table and for the third table, the difficulty table and the challenges table, we have difficulty level, which is the common column in both the tables. So we can join these two tables on the difficulty level column. So the fourth table, that is the submissions table. For this we have four columns. Submission ID, which is the ID of the submission. Hacker ID is the ID of the hacker who made the submission. And the challenge ID is the ID of the challenge, and score is the score of the submission. So please note that here the hacker ID is the ID of the hacker who created the challenge, and here the hacker ID is the hacker ID who made the submission. So both these hacker IDs are different, so we cannot join our tables on this. Instead, we can join our table on the column which is challenge ID. So we see the challenge ID is the ID of the challenge, and here also it is the challenge. There's one more thing to note, that the score of this table. So this is the score of the challenge, and here this is for the submissions table, this is the score of the submission. So these two scores are also not the same. So let's start joining the tables now, and afterwards we will retrieve the columns that we need. So let's begin writing the query. Select from. So the first table that we will be joining here will be the difficulty table. Difficulty. We give it as the name as D. We will be doing the inner join operation, and we will be joining it with the challenges table. On difficulty challenges, I'll give the alias as C. So we will be joining it on difficulty level column. So D dot difficulty level is equals to C dot difficulty level. Okay. So we have joined the table 2 and table 3 here. Now let's join the table 4, that is the submissions table. Again, we will be doing the inner join operation, and we will be joining. We'll give it as alias as S, and here we will be joining the tables on challenge ID. So C dot challenge ID is equals to S dot challenge ID. Now since we have joined second, third, we are left with the hackers table now. So we will join the hackers table here, hackers. Let's give it as H. We will be joining it on hacker ID column. Okay. So we have hacker ID here, submission. So S dot hacker ID is equals to H dot hacker ID. So we are done with joining all the tables. Now let's see what is the condition given over here. So we have to write a query to print the respective hacker ID name of the hackers who achieved full scores for more than one challenge. So we want the name of the hackers who achieved full scores. So in order to find out the full scores, the score of the challenge should be equal to the score of the challenge should be equal to the score of the submission, right? So the score of the challenge that we can find is from where we will be writing a condition d dot score is equals to s dot score. Okay, so this fulfills this condition, that is this score condition. Another condition that we have here is we have to who achieved full scores for more than one challenge. So in order to find the hacker ID and hacker name of the people who has got, so since we want to find the hacker, so s dot hacker ID, since we want the hacker ID of the people who has submitted the challenge, so I took the hacker ID from the submissions table, and since hacker name, that we can take it from the hacker table. Okay, now the count of the challenge has to be more than one, so we will do the group by on hacker ID dot hacker ID and hacker name h dot name having count of challenge ID, sorry, count of c dot challenge ID. So this count has to be greater than 1. Okay, at the last we were given that we want to order our output in descending order by the total number of challenges in which the hacker earned a full score. So at the last we will use the order by operation, and since it is given that we want to order with the total number of challenges, so the count of challenge ID we are doing here, challenge ID, it has to be descending and by the total number of challenge, and at the last we are given that if more than one hacker received full scores in same number of challenges, then sort them in ascending hacker ID. So if in case anything comes in, so we will be doing it in the ascending order. Okay, so let's run the query and see. So we have got the final answer. Here we are given a table of functions which contains two columns x and y, and we are given a condition that two pairs x1 y1 and x2 y2 are said to be the symmetric pairs if x1 is equals to y2 and x2 is equals to y1. Now we want to write a query to output all the symmetric pairs in ascending order by the value of x, and we want to list the rows such that x1 is less than equal to y1. Now we are given sample input table and sample output table. So let's observe the sample input table and sample output table to understand the question here. So here in the sample input table, we are given two columns x and y, and we are given 6 pairs. So since we want to find out the number of symmetric pairs in the output, so to find out the number of symmetric pairs, we were given a condition that x1 is equal to y2 and x2 is equal to y1. So by carefully observing this table, we can see that pair 1 and pair 2 are the symmetric pairs. Pair 3 and pair 6 are the symmetric pairs. 20, 21, 21, 20. So 20 x1 is equal to y2 and x2 is equals to y1. Similarly, 23, 22 and 22, 23 are the symmetric pairs. Now we want to mention the pairs only where x1 is less than equal to y2. So here, since here x1 is equals to y2, we have mentioned this pair. Here x1 is less than equal to y2. So 20, 21 we have mentioned this pair, but we have not mentioned 21, 20 because here x1 is greater than y1. Since we wanted to mention x1 less than or equal to y2. So we have ignored the pairs 21, 20 and 23, 22 since they does not satisfy our second condition, which is this. So okay, let's begin writing the query. So here we will be doing self join since we are given the same table. Select from the table name is functions. I'm giving it as alias as f1 and I'll do join operation here with the same table doing self join on the condition which I'm already given here of the symmetric pairs condition, which is f1 dot x is equals to f2 dot y and f1 dot y is equals to f2 dot x. Okay, so make it small 1. Okay, now we are also given another condition, so I'm writing it down in the where clause, which is this. So f1 dot x has to be less than f2 dot y, and we want to find the pairs, that is f1 dot x comma f1 dot y. Okay, so let's run this code and see what it gives us. Just a second, join this. Sorry, it has to be f1 dot y. Okay, since it is x1 less than equal to y1, so f1 dot x less than f1 dot y. So let's see what it gives here. See the output here. So since our this condition less than condition getting satisfied, but if we carefully see, we are given less than equal to condition. We don't see any equal to pair here. Only x1 is less than y1, x1 less than y1, 9 less than 17, 2 less than 24, or similar, all these kinds of pairs. So we want to write for the equal condition as well. So we will be writing it using subquery f1 dot x in. Now select x from functions, and since we want to select the equal number of pairs, so x is equals to y, but also we want the symmetric pairs. So symmetric pairs will be only when there will be the duplicate pairs. Okay, so the count of these pairs has to be greater than 1. So in order to find the count of the pairs, we will first apply the group by function on the pairs group by x comma y, and then we will take the count of this count star. It's supposed to be greater than 1. So this function will take the duplicate pairs. So let's run the code now and see what the query gives us. So now we can see the equal pairs are also coming. Okay, but since we want only the unique records, then we will use the distinct function here in order to remove the duplicates. Distinct. Now if we see, only the duplicates are removed and we only have the one occurrence of 1313 pair. Before we had 4 occurrences of 1313. Now at the last, what we are given one more condition, that we want to output all our symmetric pairs in ascending order by the value of x. So we will use the order by function here and in the ascending order of x. So f1 dot x. Now let's run the code and see. It gets the answer now. And yeah, I hope it's clear. Here we have three tables: students, friends, and packages. Student table contains two columns, ID and name of the student. Friends contains two columns, ID and the friend ID. So this is friend ID is the ID of the only best friend. Now the packages contains again two columns, the ID and salary offered. So let's see the table structure. This is ID, this is name. So this is about the students table. This is the friends table, this is the ID and the best friend ID. Now this is the packages table, so this is ID and this is the salary. Now we have to query the output names of the students whose best friends got offered a higher salary than them. So this is the main filter that we have to use. I mean, we have to output the names of those students whose best friend salary is more than their salary. And at last we have to order by names in the salary amount. So we at the last we can just use the order by operation here. So one important thing to note that is we need to join the tables in such a way that we can compare the salaries of the students with the salaries of their best friends. Okay, so let's start joining the tables and select. So the first table that we will be joining here is the students table. Yeah, wait, st students, giving it as alias s1. Now we will be doing inner join here. The second table that we have is the friends table, giving it as alias f. We will be joining it on id column. So this is the common column between both the tables. So s1 dot id is equals to f dot id. Now we have to uh, join this result with the package table twice. Why twice? Because one to get the salary of the student and other one to get the salary of the best friend. So we will be joining the packages table twice. Okay. So again we'll do the inner join operation, and this is the packages giving p1 on first we will be doing on id. So this is s1 dot id is equals to p1 dot id. Now we have to join it once again, packages p2. So this time we will be joining on friends id. So this is f dot friend id is equals to p2 dot id. Okay, now we had a condition like the best friend's salary should be greater than the friend's salary. So this is the friend id. So p2 dot salary, p2 dot salary is greater than p1 dot salary. At the last we wanted to order by the names of, or names must be ordered by the salary amount offered to the best friends. So at the last we will do order by. So order by, let's say what we have to find salary, sorry, names of the students. So this is name. Okay, so these has to order by p2 dot salary, p2 dot salary. Why P2? Because here we have to order by the salary amount offered to the best friends. So let's run our query. See, all the test cases passed. So this is the final answer. Here we want to query the average population for all the cities in the city table, which is shown here. So the details of the table has been shown here. So we do have the columns ID, name, country code, district, and population. And we just have to find out the average population for all the cities. So let's write the query. Select from, we have city table. We only want to find the average population. So we will use the aggregated function here, that is average. And we will do it for population column. So also we have been said that we have to round down to the nearest integer. So we will use the round function also. Okay. So let's run the code. And we have got the answer. So one question that may arise here is, why haven't we done group by operation? So in this context, the group by operation is not necessary because since we are calculating the average population for the entire city table rather than grouping the data by any specific column. So group by operation is used when you need to perform an operation like average, sum, or the count, etc. for each group of rows. Okay. For each group of rows that share the same value in specific column. So here, for example, if you wanted to calculate the average population for each different state or country within the city table, then we might have used the group by operation. So in this case, we don't need to use the group by operation. And let's try to do it with another method. So another method, since I used round function here, so there is one more method in which we will not be using the round function. So from city again, and the second method is, since we have to do average of population, no need. So if we don't want to use the round method, let's do it with the floor method. Floor. Now what does floor do? The floor function actually rounds the result of the average population to the nearest integer. Okay, so this is what the floor will do here. And I believe, so again we have got the correct answer. So here we have to query the sum of the populations for all Japanese cities in city table. And we are given that the country code for Japan is JPN. So we're just given a table and these are the columns of this table. And we just have to find the sum of populations for all Japanese cities. So I'll just select from city. This is my table name. Now we since I'm given a filtering condition that I only want to find the sum of the populations for Japanese cities. So Japanese cities, how will we do it? The country code, I'm given the country code of Japan. So JPN. So this will give me only for the Japan cities. And to find the sum of populations, I'll simply make use of the sum function, sum of population. So this will give me the sum of populations for all Japanese cities. So I'll just run the query and see the output. So here we can clearly see that we have got what we wanted. It has given me the sum of the populations of specifically for the country code Japan. So here we are given a table. The table name is BST. It contains two columns, N and P, where N represents the value of a node in binary tree and P is the parent of N. And we have to write a query to find the node type of binary tree ordered by the value of the node. Output one of the following for each node. root, leaf, inner. So let's see the input table and the output table. Here we have n in P, so this is the node, and this is their parent node. So let's see the binary tree and understand. So here we can see 1, 2, 3, 5, 6, 8 and 9. So these are the nodes, and the parent node is like the parent node of 1 and 3 is 2. Similarly, the parent node of 2 is 5, and the parent node of 6 and 9 is 8, and for 8 it is 5, and 5 is the root node. It does not have any parent node. Also 2 and 8 are the inner nodes, and 1 and 3, 6 and 9 are the leaf nodes, because they don't have any node under them. Okay, so these are the leaf nodes. Now, so we just have to write the names of the nodes 1, 2, 3, 5, and followed by their type of the node. So this is how we have to structure our query. So to structure this, we will be using case when statement. So in this case, the very challenging part is to differentiate between the nodes, whether it is a leaf node or whether it is an inner node or whether it is a root node. So we, from the table, if any if the parent node of any node is null, for example 5 does not have any parent. Node 5 does not have any parent. That means the 5 is the root node. It is very clear that if p is null, that means that is the root node. And then we will have to figure out between the inner node and the leaf node. So now for the leaf node, we can easily see that a node will be leaf if it is not present in the parent. Okay, if it is not present in the parent, so that will be the leaf node. So 2, 8 and 5 are the parent nodes. 2, 8 and 5. 1, 3, 6 and 9, since these are not present in the P, so these are the 4 leaf nodes. So let's begin writing the query now. Select from, my table name is BST, and I just want to retrieve node n followed by their respective type of the node. So to find the type of the node, we will be using case when statement. So here case when, since we already discussed that if p is null, then it will be root node. So we can clearly write here p is null. If when p is null, then it will be root. Now for to differentiate between leaf and inner, we already discussed that a node will be leaf if it is not present in the parent parent p column. Okay, so let's find out the count of the nodes which are present in the parent. So if this count comes out to be 0, then that node will be said to be the leaf node. So to find the count of the node which is present in the parent, we will simply use a subquery. So here we will write a subquery to find that count. So here select, I'll take it from BST table again. So this table I'm just giving it as alias B, and here also I'm taking it as B. So from BST, so I'll just write a condition that if B dot n, if this node is present in my parent P column, and so this is my query. So it will just count, it will just give me the count of the nodes which are present in my parent. So if this count comes out to be 0, then my node will be leaf node. Then my node will be leaf node. Else, since we already discussed about the root node and the leaf node, now else my node will be the inner node. I can simply write this in my else statement. I don't really have to differentiate for the inner node. And there is one more thing, end, or else that's not really very important, but also we will write. Also, let's order by n, b dot n. So this is how I can easily differentiate. So this will give me the respective node, and this case when statement will give me the node type. So let's run the query and see the results. So we can clearly see that we have got what we wanted. Here it is the node and this is the node type. So here we have one table, that is the occupations table, and we have two columns for this table. First one denotes the name of the person and the second column denotes the respective occupation of that person. So here we have to generate the two result sets. That means we have to write two separate SQL queries. So for the first query, we want to find the alphabetically ordered list of all the names in the occupations table, immediately followed by the first letter of each profession as a parenthesis. So here what do we have to do? We just have to alphabetically list down the names of all the persons, immediately followed by the first letter of their respective occupation. So if it is the actor name, then we will be writing it followed by the parenthesis with A. Similarly for Dr. D, for Professor P, and for singer S. We can clearly see here from the sample input and sample output table that since for the Ashley, we can see here this is followed by the professor, uh, P letter for the Kristen P, since she is also the professor, and till Samantha. Also we can see that the output is very clearly alphabetically ordered for the first query. So the first query output or output ends here, and here starts the output of the second query. So let's see what the second query needs from us. So for the second query, we want to query the number of occurrences of each occupation in occupations. And then we have to sort the occurrences in ascending order and output them in the following format. So this is how our format should be, that it should write there are a total of occupations count will be nothing but the number of occurrences of each occupation, and this will be the respective name of the occupation here. So if there are a total of 3 doctors, so our output will be there are a total of occupation count will come as 3, and the occupation will be doctor and will be followed by S and a full stop. Also last we just have to do the order by operation here. So let's begin writing the queries. So to do this, we can easily we can easily do this using concat function. We can just merge the names with the parenthesis, opening parenthesis or the closing parenthesis. We'll just make use of the concat function to do this. So for the first query from occupations, so my table name is occupations, and I want to find, so my format will be, so this is how my format is. So this is respective name, so concat name, comma, then I want opening parenthesis, okay, next comma, next I just want the first character of my occupation, that is What is the first character? So to find the first character, I'll just make use of left function. So the syntax of left function will be left in the bracket from which string I want to extract. So I want to extract from my occupation string. So I'll write the occupation string. In how many characters you want to extract? So I just want to extract the first character from the left. So that's why I have used left function here. So this will give me the first character for each occupation. Now I just want the closing parenthesis here. So just closing one I have done, and this is done. Last I just have to do the order by name. So this is for the first query. I'll just run the query and see the output. Okay, so we can clearly see that we have got what we were actually looking for. So this is giving us the names followed by their parentheses. Now we have to write the second query also. So let's write for the second query. We just want to find the count of occupations. Okay, for each occupations. So similarly, one thing to note that here is while starting off with the second query, we have to finish the first query with a semicolon so that we can run both the queries together. If you don't do this, if you don't finish the first query with the semicolon, you will definitely get an error. So this is one thing you cannot ignore here. So I have just done it here, and then I'm starting my second query from the sixth line. So select from, this is my table name. Now I want to find the occurrences. To find the occurrences, I'll need to do a group by operation here. I'll have to first do group by on the occupation column, and then I'll just aggregate it using count function, since I just want to find the number of occurrences in the occupation of the occupation column. So I'll do the group by on occupation column, and then what do I want? This line, this from there are a total of, this is common for every single sentence or every single occupation. So I'll quickly write in, there are a total of, I'll just give space here, comma. So to find the count of occurrences, I'll simply use the count function. So count of occupation. Now next I want next I want the occupation I have to write. So I'll simply write the occupation, comma, I also want s followed by full stop. Okay, one more thing to note that here is, this occupation will give me capital letter for the first. If since I want small letter for doctors, D, so here it will give me capital D, capital A. So this is not I actually want. I want it completely, the occupation should completely come in lowercase. So to convert this word into lowercase, I will just use lower function. Okay, next, also we had to do some order by operation here, that we want to sort the occurrences in ascending order and output them in the following format. That is what we have done, where occupation count is the number of occurrences of the occupation occupant. If more than one occupation has the same occupation count, they should be ordered alphabetically. Let's understand more. The results of the second query are ascendingly ordered first by the number of names corresponding to each profession. Okay, so number, so I'll just do it first by the count of occupation, and then it will automatically give me in the ascending order. And then if in case there are for each the count comes same, then we have to do it alphabetically by profession itself. So this is how it should come. Okay, here also I will be doing use of lower function, because since we did it here. So let's run the code and see what it gives us. We see there is some error. Okay, so it does not really match because we left out some space here after 3 and doctors. So we'll have to put a space since already comma is there. Okay, okay. Let's run now and see. Okay, so now we can see that our output has come, and we can clearly see that uh, here we are getting whatever we wanted for the first query, and similarly for the second query. So in this question, we have a table. The table name is projects, and it contains 3 columns: task ID, start date, and end date. So task date is nothing but the project ID column. This is the start date, which is actually the when the project got started, and the end date is nothing but the end date of the project. Now it is guaranteed that the difference between the end date and start date is equal to 1 day for each row in the table. So this is something which is universal for each column, each row here. So if the start date is 1st October, the end date is 2nd October. The start date is 2nd October, the end date is 3rd. Similarly for each and every row, 3rd, 4th, 13th, 14th, 14th, 15th, 28th, 29th. So it is already given to us. Now we are also given that if the end date of the task are consecutive, then they are part of the same project. This is something which is very important sentence of this complete question. So if the end date of the task are consecutive, then they are part of the same project. Let's understand this with the table. So the 2nd October is the end date here. We can see for the task ID 2, 3rd October is the end date, and for the task ID 3, 4th October is the end date. So if the end dates are consecutive, that means 2nd, 3rd and 4th. So these are the consecutive, that means these are part of the same project. That means a project got started on 1st of October and it got ended on 4th of October. Similarly, we can see here 14th and 15th. These are consecutive dates. That means if they belong to the same project. That means if a second project got started on 13th of October, it continued to 14 and ended on 15th of October. And similarly for 6 and 9, we don't see any kind of consecutive end dates here, since 29 and then 31. So that is a complete separate project got started on 28th of October and got ended on 29th of October. And similarly, a complete new project got started on 30th of October and got ended on 31st of October. So this is very clear that if the end date of the task are consecutive, then they are part of the same project. Now, what do we want to find it? We want to query the output, the start and end dates of the projects listed by the number of dates it took to complete the project in ascending order. Here we want to find the initial start date of each project and the final ending date of each project. So this is what we actually want in our output. If there is more than one project that have the same number of completion days, then order by the start date of the project. So this is something which we will be using it afterwards in the order by clause. So let's understand the question more with the help of sample input and sample output table. Since we already had a discussion with the sample input table, we can clearly say that the start date of one project is 1, got ended on 4. Then the next project got started on 13, got ended on 15. Next project got started on 28 October, got ended on 29th of October, and another project got started on 30th of October and got ended on 31st of October. So if we want to query the initial start dates of the project, that will be 1, 2 and 3 will not come in our output because it's the ongoing project which got ended on 4th of October. So we only want the start dates. That means our start date will be 1, 13, 28 and 30. So this will be these will be the dates that will come in our start date column. Next, if we want to find the end dates of the projects, those will be 4, then 15, 29 and 31. So let's see the sample output here. We can see 1, 13, 28 and 30, which are our which is nothing but our start dates. And if we see this project got started on 1st, got this, these are the end dates. So it got ended on 4. If a project got started on 13, it got ended on 15. If a project got started on 28, it got ended on 29. Similarly, if it got started on 30, it got ended on 31st. So I hope the question is very clear. So now, to solve this question, we will make use of common table expressions. So now what the common table expressions are? Common table expressions, CTEs, are nothing but a temporary table that we will create. So we will create two temporary tables here. That means we will be writing two CTEs here. So the first CTE we will write to find the starting dates of each project, and the second CTE that we will write to find the ending dates of each project. Now you can pause the video and think and you can just spend time thinking through that how we will find the start dates of the project and the end dates of the projects. By the next second, I'll be discussing the solution. So guys, to find the start dates of the project, we will just filter the start dates that do not appear in the end dates of the table. If we can see clearly here, the start dates that do not appear in the end dates are 1, it do not appear in the end date, then 2 appears in the end date, 3 appears in the end date, 4 uh, and then here 13. 13th is again our start date that do not really appear in the end date because 14 appears here, then 28 which do not appear in our end date, and 30 which do not appear in our end date. So this is how we can easily write our CTE using a where condition, that if our start date is not present in the end date column, that means those are our starting dates of the project. Similarly, to find the end dates of the projects, we will write another CTE, and there also we will just filter the end dates that are not appear in the start dates. That means our start dates were 4, 15, 29 and 31. So we can see that 4 does not appear in our start date. We can see that 2 appears, 3 appears, but 4 do not appears. Similarly, 15 do not appears, 14 actually appears, and 29 and 31 also do not appear. So this is how we will write our CTE. And once we will find the start dates and the end dates, we will just join both the CTEs using Cartesian join, and then we can just find the start dates and end dates. So let's start writing our query now. So here we will write our first CTE, that is, guys, make sure that you write your query in MS SQL server in order to avoid any kind of errors. Or so we'll write CTE1. So this CTE we are writing it for finding the start dates. Okay, so here in the CTE I'll just select, I just want the start date, and my table name is projects. My projects, since I had a condition that my start date should not be present in the end date, so I'll just write it like that, start date not in, and select end date from projects. Okay, so this is how I have written my CTE1. Also guys, make sure that you write another column to find the row number to each start date based on their order. Why? Because it will help us to pair the start date and end date at the end. So let's just write the row number, or you can also use row or rank function here. I'm just giving the row number over. I'll just use order by start date. It will automatically order by ascending order, and I'll just give as start date rank. Start date rank. So I've just assigned this row number because the same row number we will assign for the another CTE also, and to just match the start date and end date at the end. We'll make use of this. Okay. So this is my first CTE. I'll put the comma, and then I will write my second CTE. So CTE2 as select. Here I want to find the end date, and again we will just assign a row number function, which is nothing but a window function. Row number will just give me uh, the number or kind of a rank over the same we did as order by. Since we want end date here, so it will be on end date as, and I'll just give it end date rank, the same way I did for start date rank. Okay, now I have to apply the condition that I just want to filter only the end dates that are not present, or that they do not appear as the start date in the projects table. So here my end date not in start date. Select start date from projects. Cool. So this is my second CTE. Now what will I do is, now what this CTE will give me, this CTE will just, I have to put comma here. Now this CTE will give me the start dates, which are nothing but 1, 13, 28 and 30, and it will just give me the row number, that is 1, 2, 3, 4. This is how my output of this CTE will come. Similarly, for the output of the second CTE, it will be 4, then 15, 29 and 31, and the row number 1, 2, 3, 4. Okay, so now I just have to join both the CTEs. Now we will simply join both the CTEs without any explicit join condition, so that will result in the Cartesian product. So let's do that. Select from CTE1 comma CTE2, and here we will apply one condition that our start date rank should be equal to end date rank that we calculated here. This rank should be same, because that will ensure that the start dates and end dates have the same rank. uh, why? Because that will match us the correct start date and the correct end date of each project. Okay, so where start date rank is equal to end date rank. Cool. And what exactly we want to query? We just want to extract the start date, so we'll just write the start date which we calculated from CTE1, and the end date which will be end date which we calculated from CTE2. Also, we wanted to do some order by operation here. So if there is more than one project that have the same number of completion days, then order by the start date of the project. So we have to order by using the completion, the days it took to complete the project. So to do that, we will be using datediff function here. Now what datediff function will do is, datediff function will just calculate the difference between the end date and the final date here. So I'll just find the number of days it took to complete the project. That will be day comma start date comma end date. So it will give me the date, that is the number of completion days of each project. And if in case if there is more than one project that have the same number of completion days, then we have to order by the start date comma the last. I'll just do the order by with the start date. So this is how my query here is. So this query will give me the start date along with the row number. This query will give me, or the CTE actually, the CTE will give me the end date or final end dates of the project. And then we just join both the CTEs to find the start date, and where we just make use of this where condition, where we calculated the row number or the rank. You can also use rank function here instead of row number function. Okay guys, here a small mistake we did. We forgot to write from projects where end date not in select start date from projects. Cool. Just rechecking the query. So okay, and then last we just did from city1 city2. Okay, so guys, we can simply run our query now. So yes, we have got what we were actually looking for. So one question guys that is important here, that you might wonder why we haven't used partition by clause. This is because we haven't used partition by, because we are dealing with simple ranking of dates here. We are not dealing with the specific kind of subsets or partitions that we need to do on any kind of column. So that's why the partition by clause was not really required, and I have not used that. So here we have to find the average population of all cities in city table, where district is California. So we have a filtering condition here that district has to be California. So we can easily write this filtering condition in the where clause, and for finding the average population, we can just directly make use of the average keyword. So this is the city table, and these are the column names: ID, name, country code, district, and population. So let's write the query. Select. So from my table name is city, I just have to find the population. That's all. Only one column I want. So I just want population. I'll write population. Okay. Now since I want average population, so I'll just use average keyword here. And also I have a filtering condition that my district is specifically has to be California. So district is equal to California. Okay, so that's all for this query. I don't think there is more or less much to do. So let's run the code and see the results. So we can clearly see that we have got the average population of all the cities, where the district is California. So guys, that's all for this video. Thank you.